Okay, so here I have some tungsten welding electrodes. And on the packaging it says here 2% thoriated. So these are thoriated tungsten electrodes. Now if I bring this radioactive scintillation detector beside it, you can see that this is actually radioactive. Now this is because thorium is actually a radioactive element, but most of what we're detecting here, it's actually its daughter nuclei. Here I put all the tungsten electrodes closer together so we can take a better reading. Now you can see that it says 1 microsieverts, which is pretty good. However, I wanted a stronger radioactive sample. So I'm going to be extracting the thorium dioxide from tungsten electrodes. All you're going to need for this is hydrogen peroxide and the thorium electrodes, but this will change later, you'll see. Okay, so here I have a solution of 9% hydrogen peroxide, and I'm going to start dropping in the electrodes. Okay, so now that it's starting to bubble, that means the reaction has started. So what we're doing here is we're dissolving the tungsten, forming tungstenic acid, and the thorium dioxide should just fall out of solution. Now the only problem with this is that it took way too long, and I left it for like 4 days and literally nothing happened. So instead, I did electrolysis. Here I have a solution of sodium hydroxide with 2 tungsten electrodes in it. When I turn on the power of about 5 volts, you could see at the cathode that hydrogen and oxygen is being formed, and at the anode, tungsten dissolves and makes sodium tungstate. Now as the tungsten dissolves, the thorium dioxide just falls out. Here it's been an hour and you can see one of the electrodes is starting to dissolve. And at the bottom of the beaker, you can actually see a little bit of thorium dioxide. Now that I've dissolved about 5 electrodes, I stopped the electrolysis, because it just took too long. Okay, so now I'm just going to decant off the supernatant. Here's the thorium dioxide that settled to the bottom. Okay, so now I'm just going to transfer all of the thorium dioxide suspension into a small vial. As you can see here, the thorium dioxide is beginning to settle at the bottom. While the thorium dioxide is settling, I'm going to prepare a vacuum desiccator. Now that the thorium dioxide has settled, I sucked off the top layer of water, and I'm going to put it in my vacuum desiccator. My pump was able to get it to about 27 inches of mercury, which is more than good enough for this. Okay, so here I have the final product of thorium dioxide. I didn't measure how much it is, but it looks to be about a gram. Good enough for my purpose. Just a collection. There we go. Now I'm just going to measure how radioactive it is. It's So I'll turn on my Geiger counter. First I'll see how many counts per minute this detects. It works better from the back. I'll show footage of that soon. You definitely hear it's screaming. Around 4.5 counts per minute. 4,500 counts per minute. And then 140 roentgens, which is about 140 microsieverts, but if you measure it from the back, it'll show about 2 microsieverts, which is definitely better than the rods on their own. Especially the count rates, not the dose rates. So here's the dose rate and count rate from the back. You can see that it says about 5,000 counts per minute and about 2 microsieverts. And you can see at the bottom where it says hardness, it says it's detecting thorium-232. You can even see from the spectrum that it's thorium-232. Okay, so thanks for watching this video. Hope you enjoyed, and if you want more videos like this, make sure to like and subscribe.